the importance of Swift's migration tooling and its impact on upcoming Swift features. Let's start with the basics. What are upcoming features? Some of you might be subscribed to my Swiftly weekly newsletter. I highlight the proposal state changes for every week, and it's based on the GitHub repository where you can find all the proposals for all the upcoming Swift's features. Swift is open source, so you can follow along if you will. And in this case, we have an overview of 3 proposals that are in active review, but also 1 proposal that is already implemented. There are many states also accepted, for example, or back to review. And if you will, you can dive a little deeper. This is the GitHub repository. It's the Swift Evolution GitHub repository, and it contains all the proposals, even from 7 years ago. This is like the whole history of all the features that you know that exist today in Swift. And here we have an example where we run a non-isolated async function on the colors actor by default. Just reading the title might confuse you quite a bit, but you can zoom in and learn a lot about the details. First of all, we can see that this is already implemented and available in Swift 6.2. We can also see that it's related to a vision document. In this case, it's related to improving the approachability of data race safety. Highly encourage you to read that vision document, as it's kind of like setting the direction for the future of Swift and for the future of strict concurrency, Swift concurrency. And for this proposal, we also see an upcoming feature flag. And for this video, that is key because we will talk about migrating to this upcoming feature and why it's crucial to not do it manually. More about that later. And these proposals are truly a gold mine. This is the motivation section, and each proposal has the same structure, right? So it comes with the motivation section to explain you like, why are we proposing this change to the Swift language? And it contains a lot of interesting background information. Here, for example, in this proposal, this decision has a number of unfortunate consequences. They're talking about how Swift used to be and how they found out that its impact was negative, right? Like that they didn't expect something to work in the way it actually did. So they're now revisiting this and applying changes to the language accordingly. And in this video, I'll demonstrate what you can do with the upcoming feature flag. So I'm copying it into the build settings, and you can see that approachable concurrency shows up. And it's because it's being enabled if you enable approachable concurrency as a build setting. We can also search for the upcoming feature specifically, and that allows you to look into a quick summary explaining what the feature is about, and also finding a declaration which you can use to match the upcoming feature flag. Now it's important, right? You can enable this feature by enabling approachable concurrency, but enabling that build setting will automatically enable a lot of other build settings too. And this will impact your project's build settings as well as the outcome result of it. Code that behaved in a certain way might suddenly behave differently. And that aspect is crucial for existing code bases. More about it later. Here we have a Swift package file, and what you basically do with the proposal is you match the Swift version and you use the upcoming feature flag to enable it using the Swift settings. This is basically how you do it for Swift packages. Now let's look into the importance of migration tooling. And I want to do that by looking at a piece of code. We have a class that is not sendable just because we didn't adopt the sendable protocol in this case. We have a single perform async method, which is an async method, and it prints the current thread where it runs on. And imagine calling this method from a struct that is attributed with the main actor. Logically, this starts on the main thread. You can see that on the right side. Then we await to perform the async method. And looking into that method, we can see that it's running on a background thread. the global executor dispatched it to a background thread, which is what we expected. And eventually we return back and we run on the main thread. Now, this is the old behavior before we enabled any of the new upcoming features. Imagine now going into the build settings and manually enabling this upcoming feature. Nothing stops you from doing this. And if we now go back to the code, we start on the main thread. Then we go into the perform async method. And that suddenly behaves differently. Now it runs on the main thread. So you changed one build setting and your whole project behaves differently. And this impact can be big, right? Suddenly your UI is being blocked way more often, resulting in performance issues, potentially even resulting in an App Store rejection. So this is crucial, and this is why migration tooling is so important. We return, we're still on the main thread. And in the background, this is what happens, right? So implicitly, your method becomes non-isolated, non-sending by default, because that is the upcoming feature that we enabled. So it's not tied to a specific actor's isolation, and it does not send the object or the state to another isolation domain. And this is what we've seen happening, right? We stayed on the main actor because the callee was attributed with the main actor, making it isolated to the main actor's domain. So I want you to better understand this upcoming feature, right? So non-isolated, non-sending in Swift runs in the caller's context. It doesn't hop to another actor or executor. It stays where it's called, exactly what we've seen in the previous code example. There's no implicit domain switch, so it avoids unnecessary concurrency hops and complexity. And due to that, you also don't need sendable protocol everywhere. And you can imagine its impact on approachable concurrency this way, because it reduces a lot of requirements of adopting sendable for all kinds of types. And that's why this upcoming feature is so impactful. Now, this is another way what you can do. If you enable the migrate setting and you build your project, a warning shows up on all the lines that will be impacted by that upcoming feature. And if we click on that warning, you can see an apply button to apply and fix it directly, but you also see a question mark, and that allows you to learn more about the upcoming feature. And that documentation is quite a recommended read, right? Especially if you're now focusing on just that upcoming feature, you stay in that context, right? You really teach yourself how that method works and you go through your whole code base. At least that's what I recommend, right? So see if you can focus on just one upcoming feature at a time, read up on it, migrate it, and then continue to something else. What Xcode requires us to do, or it suggests us to do, is to add the add concurrent attribute. And this is what you probably want to do for all the warnings that show up. You might realize like, hey, this is actually fine to run on the callee's actor's isolation. That's fine too. Then you leave the concurrent attribute away. And if we then run this code, we start on the main thread. We go into the perform async method, which runs on the background thread. And then eventually we return back on the main thread. So we restored the old behavior, but we opted into the upcoming feature. So the importance of migration tooling is pretty clear, I would say, right? Manual migration doesn't scale. I've been there myself, right? Migrating 20 plus packages for Rocket Sim. It's so easy to make mistakes. You introduce risk by doing it all manually. And automation accelerates progress, right? It goes much faster. A migration of months suddenly becomes a migration of weeks. Now, there is much more to tell you. You can actually migrate Swift packages as well, and there's a way to automatically apply all these changes. For that, I highly recommend looking into the description of this video, where you'll find a link to my course, which offers 65 plus lessons at the moment of making this video, because I'm adding much more in the future. So make sure to check it out. And otherwise, I also have a free 5-day Swift Concurrency Playbook, which goes over the 5 biggest mistakes I see iOS developers make when working with Swift Concurrency. Make sure to sign up with the link in the description. Thanks for watching this video.